Hi students, in this class we are going to solve a numerical problem on the ABCD constants of nominal T network of transmission lines. This is our sending in voltage, this is the sending in current in terms of ABCD constants, where A equals D equals 1 plus YZ by 2 and B equals Z plus YZ square by 4, C equals Y. If we find out ABCD constants and if you have the receiving end voltage and the receiving end current with you, you can easily find out the sending end voltage and the sending end current. In this problem, the receiving end power is 30 megawatt, the receiving end voltage is 132 kilovolt, the power factor is 0.85, the impedance of the transmission network per phase is 20 plus J52 ohm. The admittance of the capacitance is 315 into 10 raised to minus 6 mho. Using nominal T method, we have to find out ABCD constants and thereby the sending end voltage. Now these are the transmission line parameters and the load parameters. Let's first find out the ABCD constants. So A equals D equals 1 plus YZ by 2. Here Z equals 315 into 10 raised to minus 6. So let us J into 315 10 raised to minus 6. Because you know capacity reactance X is equal to 1 by minus J into C omega. Admittance is inverse of the reactance. So this will be in the form of J into Y. Because 1 by minus J equals plus J. So this is equal to 1 plus J 315 into 10 raised to minus 6 into Z equals 20 plus J 52 divided by 2. So this is equal to 0.99 plus J 0.00315. So we got the constant A equals D equals 0.99 plus J 0.00315. And the constant B is equal to Z plus YZ square divided by 4. This is equal to Z is 20 plus J52 plus Y equals J315 into 10 raised to minus 6 into Z square is 20 plus J52 the whole square divided by 4, and this is equal to 19.84 plus J 51.82. So the constant B is equal to 19.84 plus J 51.82. The constant C is equal to Y is equal to J315 into 10 raised to minus 6. So the constant C equals J315 into 10 raised to minus 6. Now we got all the 4 ABCD constants. Now we have to find out the sending end voltage and the receiving end voltage and the receiving end current. BR equals 132 kilovolt. The voltage given in the problem is the line voltage. We have to find out the phase voltage. We assume that it is a star connected system. So the line voltage equals √3 times phase voltage. So the receiving end phase voltage is 132 into 10 raised to 3 divided by √3. So this is equal to 76210 volt. This is the magnitude of the receiving end voltage. We have to write all quantities in the vector form. So vector VR is equal to, as the receiving end voltage is taken as the reference vector, it is 76210 plus J0, because this is taken as the reference vector. So VR equals 76210 plus J0. Now we have to find out the receiving end current. So you know P equals √3 VL IL cos phi. So the receiving end line current equals P divided by √3 into VL cos phi. Here power equals 30 megawatt. That is 30 into 10 raised to 6 divided by √3 into the line voltage is 132 kilovolt into the receiving end power factor is 0.85. So the line current equals 154 amperes. This is the line current. We have to find out the phase current. As it is the star connected system, the line current is same as the phase current. So the receiving end phase current is also equal to 154 amperes. This is the magnitude of receiving end current. We have to write this receiving end current in the vector form. IR vector is equal to the magnitude into cos phi r plus j sin phi r. Here phi r equals, the receiving end power factor is 0.85. From this we can find out phi r, the receiving end phase angle. It is 31.78 degrees. As the power factor is lagging in nature, this is negative. That's equal to 154 into cos minus 31.78 plus j sin minus 31.78. So this is equal to 131 minus j 81.62 amperes. So this is the receiving end current in the vector form. So IR equals 131 minus j 81.62 amperes. Now we got ABCD constants and receiving end voltage and receiving end current. We can easily find out the sending end voltage. The sending end voltage equals, in terms of ABCD constants, it is A into VR plus B into IR. So Vs equals A equals 0.99 plus J 0.00315 into the receiving end voltage is 76210 plus J0 plus the constant B equals 19.84 plus J 51.82 into the receiving end current is 131 minus J 81.62. So this is equal to 82276 plus J 5409. In the polar form, we can find out the sending end voltage. It is 82453 angle 3.76 degrees. So this is the magnitude of sending end voltage. Similarly, if we want, we can find out the sending end current. From that, we can easily find out the sending end power factor.